Today we are looking at completing the square, which is just another method to solving quadratics. As you can see, the steps are listed above. Step 1 is to move the loose number to the right side of the equation. So in this case, I'm going to add over the 57. Now there won't always be a number on the right-hand side of the equation, but sometimes there will be, like this example. Following my steps, it says divide everything by a. Well, we don't have an a value. No number out front, it's just 1, so it doesn't affect the problem. Step 3, complete the square by taking half of b squared and add it to both sides of the equation. So in this case, we're going to take half of b, so we're going to divide 6 by 2, and then we're going to square it and add it to both sides of the equation. That's what step 3 says. So this will be 6 divided by 2 is 3, 3 squared is 9. And that's the number we're going to add to both sides of the equation. This is the complete the square step. So a lot of people wonder where this number comes from. It's from this little formula out here. Okay, now I'm going to simplify just the right-hand side of the equation. And then the next step, step 4, is to factor the perfect square trinomial. So on the left-hand side, we're going to factor it. You can draw your x and put your 9 in the top, and the 6 in the bottom has to multiply to the top and add to the bottom. So that will be 3 and 3 for this example. As you notice, we have the same number here. That's because this is a perfect square trinomial. So really, if we factored this, it would just be, since our a value is 1, I can jump to the two side factors of b plus 3 and b plus 3, or b plus 3 squared. So for all of the complete the squares, you can always, instead of drawing the x, you can always just take half of the b value and the sign in front of it and shrink it down with a square. That will work every time for these problems. Okay, now step 5 is to solve. So we square root, we want to get rid of the square, so we square root both sides. So the square root and the square, those undo each other, so you're just left with what's underneath. And then anytime you add in the square root by hand, you're going to add in the plus or minus. Square root of 64 is 8, because negative 8 times negative 8 is positive 64, and 8 times 8 is 64. So you always have to add in this plus or minus. And then you solve. So I'm going to subtract over my 3. And so now this is technically two equations. You have b equals positive 8 minus 3, and b equals negative 8 minus 3. 5 and negative 11 are your two solutions. Remember, with any quadratic, even when we factored and solved, you will always have two solutions for your final answer. Again, you could graph the original. You would just have to add over the 2 and put this in y equals, and your x-intercepts would be at 5 and negative 11. Okay, let's try one with an a greater than 1. Let's try number 8. Following your steps from the front, step 1 is to move over the loose number. That's already done for us. Step 2 is to divide everything by your a value. This time we do have an a greater than 1. So now we get x squared minus 8x equals negative 15. Notice I left a space for my complete the square number. So now, off to the side, you take your equation, b divided by 2 squared. So my b is negative 8. So I divide it by 2, and then I square it. So negative 8 divided by 2 is negative 4. Negative 4 squared, which again is the same thing as negative 4 times negative 4, is going to give us positive 16, and I add that to both sides of the equation. If you'd like to highlight or underline this number so you don't forget where it came from, that's a necessary step when forcing this to be a perfect square trinomial. Then I'm going to simplify the right-hand side of the equation, and then I'm going to factor and solve. So to factor this again, you could draw your x off to the side and put your a times c in the top, your b in the bottom, and then two numbers that multiply to the top and add to the bottom. But these will always be the same with these problems. So you can always just take half of b and the sign in front of it and square it. Either way you want to do it. Alright, now we just solve. So I square root both sides because I want to get rid of that squared. So now I'm just left with what's underneath. x minus 4 square root of 1 is plus or minus 1. This is a key step as well. That will give you your two solutions. Remember, every quadratic has two solutions. So if you don't put the plus or minus, you're losing an answer. Last step, solve for x by adding over your 4. So now we get x equals positive 1 plus 4 and x equals negative 1 plus 4. And plot the original in y equals and look at your x-intercepts and check and make sure you did it correctly. Alright, last one. Let's jump down to number 13, kind of a tricky one. It's all out of order. This is not considered standard form. So I'm going to add over my 42x to get it on the same side as my 3x squared. But then I'll keep over the 3, because step 1 in complete the square is move over the loose number. Okay, so again, you'll want to follow these steps each time. I have it in this form. Now I want to divide everything by a. So in this case, my a is 3. So you're going to divide all three numbers by 3. All right. Now we'll take our b divided by 2 squared, add it to both sides. So in this case, that's going to be a 49 for the complete the square step. Then I'll simplify my right-hand side. So I have x squared plus 14x plus 49 equals 50. Then I will shrink or factor my left-hand side. Again, I like to use the shortcut of taking half of b and the sign in front of it and square it, because these are always the perfect square trinomials. Of course, you could draw your x out to the side to factor it if you need to. All right, looking back at your steps, we're on step number 5. That's to square root both sides. Don't forget, when you take the square root, you have to add in a plus or minus on the right-hand side. So you're left with what's underneath the radical, just the x plus 7, and it equals plus or minus square root of 50. So this one's a bit more challenging. If you're in honors, you'll have to know how to do this. This is actually part of our next unit, but we'll jump ahead. Square root of 50. 50 is not a perfect square. So off to the side, I use something called the ladder method to kind of break down that 50. Break down that radical to simplify it. So 50 divided by 2 is 25. 25 divided by 2, not an even number, so then I go up to 5. 25 divided by 5 is 5. 5 divided by 5 is 1. Then I group, since it's a square root, I group them by 2. And any grouping of 2, because remember, square root means 2 of the same numbers. For this one, or even on the front, we had square root of 64, which is 8 times 8. So that's why I could just take 1 8 out front. Here I can take 1 5 out front, but the 2 has to stay inside the radical. So then I have, I'm just going to replace my square root of 50 with 5 radical 2. These are the same thing, square root of 50 and 5 radical 2. All right. Then all you do is subtract over your 7, and then you have x equals negative 7 plus or minus 5 radical 2. This is one full term, so we can't combine the 7 and the 5 out front. So this is your final answer here. Again, this is a challenge problem. We haven't gotten to our radicals unit where we'll be simplifying radicals a lot. So don't worry if you don't understand this for now. Start back at the beginning and try some of these first couple, and then check your answer key online. Thank you guys. That is how you solve using completing the square.